All right, now in this example, this quadratic equation is one that really could be solved using the factoring idea, but I'm going to go ahead and do this with the quadratic formula so you can see some interesting things develop I want to point out at the end. Okay, so again, I need the a value. A is 1, the b is -6, and the c is 9. So those get plugged in. And I need my, also make note that I have the 0 on one side, so I didn't have to solve anything or get a 0 there. And again, I'm going to write out my quadratic formula every time. So x equals -b plus minus the square root of b squared minus 4ac all over 2a. There's the formula. Now I've got to do it with the parentheses. Okay, so negative parentheses plus minus root parentheses squared minus 4 parentheses all over 2 parentheses. Now we plug in our ABC. So the b value goes in here, that's -6 and -6. The a goes in two of these spots, that's a 1 and a 1, and the 9 goes in for c. Alright, so next step, double negative makes +6. -6 squared is +36. Always going to have a positive in this first term, unless it's 0. But no, you'll never have a negative there. -4 times 9 is -36. Interesting. Then I'm going to divide by 2. Well, here, under the root, I get 0, right? 36 minus 36. So that's 6 plus or minus root 0 all over 2. And what is the square root of 0? Well, it's 0. So that's 6 plus or minus 0 all over 2. Now, if you were to add the 0, remember how we cut this off, and subtract the 0, do one with a plus, one with a minus, 6 plus 0 is 6, and 6 minus 0 is 6. So you really end up with the same answer in both cases, which really is just one answer. So the final answer is just x equals 6 over 2, which ends up being 3. And we don't have to do it twice because you only have one solution there. So final solution is just 3. Now, if you think back to all of the previous examples that we did, the type of solution is always determined by the stuff under the root. Notice here, this was the only one that had one solution, and it came from having a 0 under the root. In our previous example, I pointed this out that the negative under the root yielded two complex solutions. And then in our first two examples, I mentioned that the positive number under the root gave two real solutions. Okay? So this number under the root is very, very important. In fact, it has a name. We call it the discriminant. The discriminant is this expression b squared minus 4ac. And it has the value of the discriminant ends up determining some very important things about the quadratic formula or quadratic equation. And so let me summarize all that here. If that discriminant is greater than 0, if it's a positive number, then there are two real number solutions. Okay, two real number solutions. Those were the first two examples we saw. If that discriminant is less than 0 or a negative number, then there are two complex number solutions. Okay. And then finally, if that discriminant is equal to 0, that's the example we just saw, then there is one real number solution. Okay, if you just think about the real number solutions, then a positive discriminant gives you two real numbers. A negative discriminant, because it gives you two complex, it actually gives you 0 real number solutions. And if that's equal to 0, then you get one real number solution. Okay, so that's a nice summary of the discriminant and how that determines the number of solutions and the type of solutions for a quadratic equation.